Hello Internet, welcome to another tutorial on Smith chart. This is the third installment of Smith chart tutorial series. In this tutorial, we'll learn how to find reflection coefficient from Smith chart. It's as easy as 1, 2, 3. I've written down these steps here. You've got to know the normalized impedance of load for a transmission system, and you plot the VSWR circle. If you do not know these two steps, I highly recommend that you watch my previous videos in this series. And then you simply need to use the compass to find the reflection coefficient. As simple as that. Now we know that reflection coefficient is a bad thing. We want it to be as low as possible, and the reason why this happens is because of the mismatch of the load with the characteristic impedance of the transmission line. For example, we have a load here. The characteristic impedance of transmission line is Z0. Because of this mismatch, some part of the signal goes back, which is not desirable at all, which causes other problems like standing wave ratio. As we can see, the standing wave ratio is dependent upon the reflection coefficient. Now in theory, we first find the reflection coefficient from this formula, and then we go on to find the standing wave ratio or the voltage standing wave ratio. But this is reverse in the case of Smith chart. Now in Smith chart, I've taken up the example from the first lecture where I took 3 different loads. I found the normalized impedances, then I plotted those impedances here, here and here, and we could find the VSWR from this circle. Now what happens is, to calculate reflection coefficient, you need to take help of these scales. These scales are extremely useful. They tell us a lot of things, but in this video we'll focus our attention on reflection coefficient. So if you look carefully, you'll find reflection coefficient here. This third line from the top is reflection coefficient. And to find reflection coefficient, what you need to do is you need to take this radius for the first transmission system. By the way, your compass will already be there. If you've drawn the VSWR circle, you take that radius and put it on the center and mark it here, and you get a value of reflection coefficient to be 0.7, which means that 70% of the signal is being reflected back. And similarly, as the circle goes on becoming bigger, the value of reflection coefficient also becomes larger. So 81% of the signal is being reflected back. And if we were to verify this with the help of formula and theory, we could do that too. For example, we have a case where we found the reflection coefficient as this. Now if you do 100 iota divided by 100 plus 100 iota, you get almost 71% of the signal, which was depicted here also at this. So we've just verified that. And by the way, if you have trouble using this calculator to perform complex number computations, then you could watch my videos. I've made extensive videos on usage of calculator. I'll appreciate if you see those videos to understand this part of the lecture well. And that's about it for today's tutorial. I hope finding reflection coefficient was easy and this video was helpful. And if it was, click the like button and consider subscribing to the channel. You have a good day, good life. Bye.